Hey friends, we're going to jump into adding and subtracting functions. We're going to give you some weird looking functions here, right? First one's not too bad. We got a nice linear function, right? Y equals mx plus b. The second one has a square root of x plus x. Really doesn't matter what it is. We're just going to follow what they ask us to do with these functions. So the first one is simply to add them together. Now, of course, the order matters. So I'm going to go 4x plus 7 plus the square root of x plus x. All right, now I put this in parentheses. In addition, it doesn't really matter, right? These are unlike terms, so it really doesn't matter. Um, but when I go to subtract them, this is going to be a big deal. So let's take a look. I got 4x and 1x. That makes 5x. I have a square root of x. It is positive. And I have a 7. Those are all unlike terms. So that is the result of adding f of x and g of x. All right, we try the same thing. I notice it's going to be the same order. Everything's going to happen except for now I have a minus sign. So this 4x plus 7 minus, big deal now, square root of x plus x, because this means this minus the square root of x and distribute minus x, which means 4x minus an x is 3x. I have minus the square root of x and I have plus 7. All right, one thing I left out on both of these because we can do it at once. What are their domains? So we go back to the very, very beginning. I have a domain issue with the square root. Right? We don't take the square root of negative numbers, right? We do, but we get imaginary numbers. So you get the idea. Right? So that means in the end, as I'm adding and subtracting those, my domain should be whatever the most restrictive domain is in the beginning. So my domain is that x has to be greater than or equal to 0. And that works for down here. X has to be greater than or equal to 0. You say, well, what about f of x? Well, in f of x, I had no problem at all, right? We're talking about a linear function, and it's a diagonal line. So that means all the real values are used for the domain, right? So we go left and right forever. All right, next thing we can do is multiply them. All right, first one's already scripted for us a little bit. You guys get the drill here. If I have this closed in dot, and you'll see the difference here in just a minute, that means we're going to multiply those two functions together. So it's all set up. I have two binomials. We're going to FOIL it. That's what we do. First, x cubed. We go to the outside, plus 3x squared. We go to the inside, minus 9x. And then on the end, minus 27. Oh my gosh, what did I do that for? 27. All right, that's it. Domain. So remember, I have x squared. That's like a parabola. And I have a linear function. So my domain happens to be all real numbers. No big deal. Next thing we're going to do is stack them up, right? F of x should go in the top. So I have x squared minus 9 over top of x plus 3. X squared minus 9. I'm pretty sure we've dealt with that quite a few times. So here's what we have. We have x plus 3 and x minus 3 over top of x plus 3. Well, I know for sure x plus 3 divided by x plus 3 turns out to be 1, so I have x minus 3. So my simplified form of f of x divided by g of x is just x minus 3. Are there any domain restrictions? Well, for sure. We just found out that x is not allowed to be negative 3. Right? We just talked about that a whole bunch. If you're in my class, you know what I mean, because we talked about domain restrictions of rational functions. So we just created one by having a fraction in this problem. Right? So that part should maybe be a little bit easier as we reordered what the textbook had. What's a textbook now? I think we work with kids and people. We know what we're talking about. All right, so I had mentioned this closed dot. That's a big deal. Let me zoom in, closed dot. Okay? Because the other thing we do is we give you this open dot, right? And all that means is we're gonna do a composition. You saw this, I hope, in Algebra 1. If you had me, you definitely saw it in Algebra 1. It means the same thing as taking this f of x right here, right, and using it inside of there. So I'm going to evaluate this function. If I have a number in here for x, take that answer and put it into g. So I'm just going to work from the inside out, right? If it doesn't give me a number, I'm going to put the whole function in there, right? And have a note here. This is not cumulative. So what that means is the order matters. If I do g of f of x and I do f of g of x, it does not always equal the same thing. It only equals the same thing in a very special situation that we'll probably talk about in pre-calc. Yeah, when we get to pre-calc, we talk about that. All right. So let's take a look. What's the first thing we're gonna do? Notice the notation, open dot, right? Open dot, that means, and it doesn't really matter for this one. It means g of f of -3. Right? So I'm going to start with f of -3. So f of negative, so this is f of x. So I'm going to take -3 minus 5 is -8. So that means I have g of -8. Okay. So it means I want -8. I'm going to use parentheses squared. So that means this end result should be 64. Oh, it's so nice to do problems where we get numerical answers again, isn't it? Man, it feels like it's been forever. Oh no. So now I said that, but now it just went away. Look at that. So of course I added this one in. We're going to take f of x. What does it tell me to put in for x? Nothing. Right? I'm going to leave x in there. So here's what we're going to do. I want g, which is x squared. So I need something squared. What am I going to square? I'm going to take this entire function. It's like substitution, x minus 5. All right. Now, x minus 5 squared. Remember that means x minus 5 times x minus 5. So I have x squared minus 5x minus 5x, so minus 10x plus 25. All right, domain restrictions. I don't have any in this one. I don't even know if that was something I was supposed to talk about. Oh my gosh. Nope, we dropped it for right now. Okay. So we're all set there. Now, to prove the point that the order matters, what if, oh wait, no, I didn't do that. Oh man, notice this is exactly the same thing, right? So that was all intentional, except for me forgetting. That was not intentional. Sorry about that. So I'm going to take this entire answer that I just got, x squared minus 10x plus 25. If you want to start over and do that twice, that's totally okay. Totally okay with that. I don't know why I keep saying totally. Now I said it again. All right. I'm going to multiply it by -2. If we have a multiplier out here, I could have like +8. I can do anything I want to it, right? We're just saying do this, follow the order of operations. That's all we're really doing, but having you work with entire function instead of just some numbers. All right, distribute -2x squared plus 20x minus 50. All right, so that's 2 times g of f of x, and that's how we say that, g of f of x. All right. So that's composition, very different than foiling it together or multiplying it. So we get a couple here, you could try them out. All right, otherwise, you know how it works. We're going to do some pair deck in class. Eventually, we may do some of these for some homework or worksheet. I'll see which one seems best as we work through our pair deck. All right, but that's 6-6, operations with functions, my friends.